Okay, so the project chosen is a disk detective, and this project is based on the data collected from the WISE mission or the All WISE data. And the WISE or the Wide Field Infrared Survey Explorer was launched in 2009, and by early 2011, it scanned the sky twice in infrared light, and therefore snapping pictures of almost three quarters of a billion objects, including stars, asteroids, and remote galaxies. And therefore, through this activity, we will be mining and examining images of disk candidates from the NASA WISE mission. And we'll also be comparing them with images from four different astronomical surveys. The surveys are Sky Mapper, Southern Sky Survey, the Pan-STAR Survey, the 2 Micron All Sky Survey or 2MASS, and the Unwise co-ads of data from the WISE mission. And therefore, this disk will be finding are known as the YSO disk or the debris disk. And these are circumstellar disks or a belt of material around the star, mostly made up of dust left over from collisions of rocky bodies, which then form planets. And therefore, we call some of these disks the young stellar objects or YSO disks because they orbit pre-main sequence stars or primordial disks. Yeah, and therefore these systems are gas rich, and some of the systems are known as protoplanetary disks because they are also disks from which planet forms. And therefore, why we need this project is because the WISE images can confuse a disk hosting star with a galaxy or nebulosity between the stars, and therefore need visual inspection, and where it needs visual inspection of objects in multiple wavelengths, which includes optical inspection and infrared light inspection to differentiate them. So our goal is to find good candidates of circumstellar disks so that they can be further processed and analyzed by the science team. Okay, so we'll be looking at these images, and our aim is to find a single round sourced image which is contained within the red circular input in most of these pictures. And through these images there might be certain deviations and certain images which could not be used, and therefore we take account all of these images which can't be used and what's wrong with these images. And later in the last part of the project we categorize what's wrong with the image, and if there's nothing wrong with the image, then we choose none of the above, as you will see later. And this would help us filter the image on finding the good circumstellar disks. And we also can use the invert image button, which could reveal certain details if we are not sure whether the image or the circumstellar disk being observed extends extends past the red circle or not. And while comparing this image, sometimes different image reveal different stuff, such as the Pan-STAR survey. It's good at revealing objects like galaxies, which are not round and which could not be used in finding circumstellar disks. And also, the unwise image from the WISE telescope could reveal the interstellar dust clouds. And we also take conditions such as like the pan-star and sky mapper image, which sometimes might have bright rays or spikes or bright rings with black pixels in the middle. And these cases is when what happens when the star is too bright and they overwhelm the telescope's camera. And we take account of all these of these discrepancies and errors, and we categorize them in the last part of the project, and submit this image to the science team. The one example of the images that we're going to look at. So if I press play, we could see the images being compared with each other, and you see in the last two wise images, the image being observed is out of the red circle, extends beyond the red circle. Therefore, therefore, we select the category of the object extended beyond the outer circle in the unwise image, and submit it. And therefore, the image gets submitted. So this is one example. Okay, so these are the collected data from the survey, And as we see from the first collection of images, we found that the object that we are trying to see, as you see here, is extended beyond the circle in the unwise image. There's unwise W3 and W4, and in both of those images, the object extends out of the red circle, and therefore we categorize it in that error and we submit it. And similarly, this part of the survey, we find no errors, and therefore we find a perfect circular circumstellar disk which is contained within the red circle. And therefore, we click none of the above and submit it. And this image, on the other hand, is extended beyond the red circle for the unwise images. And this, on the other hand, the object moves out of the crosshair of the image in two or more images. And for the both Pan-STARS survey, the images is not in the center, and therefore we click this, we categorize it in that error and submit it so that these images could be excluded from the observations. And lastly, this fifth one, we find that the object moves out of the crosshair in two or more images, and also in the unwise images, the object extends out of the red circle, and therefore we select these two categories of error and submit it. And so from this project, the one thing I've learned is how astronomical projects such as the Hubble mission or the WISE mission, it's being and data from the missions are being concised from such a huge array of data from billions and billions of images into research material and images that we can actually use to analyze and learn more about our universe and solar systems. And I also learned that projects which involve citizen help, such as the Galaxy Zoo Hubble or the Moon Zoo project, which helps map our moon and such, is very useful, and a lot of astronomical projects benefit from it because it acts as a filter from with certain instructions. We could use citizen help to filter these images and filter this data before we could use this in our research. Use this as research material, and we could study these images, and this helps save us a lot of time and therefore progresses our project much faster. One thing I would like to know further about this project is what's next. How do we further filter these images in determining the best circumstellar disks or YSO disk, and how do we determine the formation of planets or the stages in formation of planet from these images, and what kind of software is used and how it is used to find formation of planets, or in the its role in in identification of extrasolar or interstellar planets. And another thing I would like to know is how do we identify false positive from the software, and how do we remove them? And thank you.